In this example, we want to study exponential growth. I say growth because both of these bases are greater than 1. We have 3 and 5, so we're trying to graph f of x is 3 to the x and f of x equals 5 to the x. And any graph, any exponential growth function, all right, okay, so there's my axes. They're going to look like this. Here's 1. And I'm graphing f of x, just a generic f of x equals b to the x. You only have to know 2 points for this. Okay, so it's this point, 0, 1, and then 1b. Okay, so 1b, and here we have 0, 1. Okay, and these functions will come along, they're crawling along, and then suddenly they get ready, and then they blow up. Boom. So the bigger b is, the faster they're going to blow up, or the steeper this slope is going to be. Okay, so let's look in particular at 3 to the x and 5 to the x. Let's do 3 to the x first. We'll graph it in blue. Okay, so 3 to the x is going to cruise along. I'm not going to do it point by point because I want to get more into the habit of just using these 2 anchor points. So we go through 0, 1, and then by 1 we go up to 3. That tells us how steep we go. So it goes to 1, 3, and 0, 1. All right, so it's going to crawl along like this, and then it comes up, and off it goes. All right, let's look at 5 to the x. And we'll do this on the same set of axes just for comparison. 5 to the x we'll do in green, cruising along. All right, they look very similar, and then it's going to come in a little less steep, and then it's suddenly going to go even steeper. It's still going to go through 0, 1, and then by the time we get to 1 on the x-axis, 5 to the x is already up to 5. So it's going to take off even steeper and go up like that. Okay, and you can imagine 10 to the x would come in even more shallow and turn up even steeper, right? So you can graph with any base you would like. The bigger the base, the steeper the graph.